Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hello. Hi, everyone.
Hi, everyone.
Excited to host this session as part of the AI Agents Hack. I know we kickstarted yesterday with a great show, so let's keep this going. Today we are going to build our code-first application with Azure AI Agent Service. I'm Carlotta Castelluccio. I'm a cloud advocate at Microsoft, focusing on artificial intelligence. Marlene, do you want to briefly introduce yourself?
Yes, I am Marlene Mangami. I'm also a senior cloud advocate on the Azure for Python team. So good to see you all again. I saw some of you yesterday, so nice to see you back.
Yeah, and thanks for sharing where are you joining from. Keep doing so. We are so curious. I'm joining from Italy, by the way.
Yeah, I'm in London, so all over the place. It's nice to see everyone.
Absolutely. Great. So let's get started and let's set the scene for today, for the next 45 minutes or so, which we're going to spend by exploring AI agents through an end-to-end example created with the Azure AI Agent Service that address a specific use case, real-world use case. But before jumping into our sample and our session today, let me do just a step back and let's start with the why. So why do we even need, agentic AI? What's the benefit the agents brought with respect to just consuming large language models? So in this slide, you can see the AI progression in the last year or so. We started with interacting directly with large language models, which can take natural language as input, speak many languages. They can process multimodal inputs and outputs. We are kind of getting familiar with interacting with large language models, right? They can carry out tasks and also act as tutors. But in terms of user experience, they basically provide a simple back and forth chat with users. And they can also be grounded on private data, business data, for example, to be able to provide more accurate responses or even customize through fine-tuning techniques. Next, in the middle stage in here in the slide, you can see that we have triggered agents, which is one step further. Basically, these agents are goal-based and they can take actions independently on behalf of the user. They are still based on large language models, of course, as the model is basically the engine of the agent, but they also have access to data or search tools and also to actions. So basically, they are semi-autonomous because they may require minimal user intervention, but they could also ask other agents for input. So given a goal, they will work to achieve that goal without you or the user knowing in advance exactly how it's going to do that or what steps it's going to take. And they also have a memory because agentic frameworks handle the conversation context and token truncation for you. So as I mentioned before, an agent can work with another agent, and that's how we move to the third and last step here in this slide, where we have multi-agent systems that can be built to address more complex scenarios where we want to provide full tolerance, for example, so one agent reviewing the work of the other, specialization, so we want to have agents specialize in different things, and scalability for large workloads. So in short, if you want to summarize, an agent should be able to accomplish three things. First of all, reason over a provided business process, integrate with data sources for context, and orchestrates a process towards achieving a goal by performing actions. So basically, an LLM-based agent is a framework that sits above one or more models, because we can also have multi-models agents, that allows you to do complex long-running tasks and that can take action on behalf of the user. So now, as I promised it, we have a real-world use case for today and an end-to-end sample that addresses it. So let's see how an agent can help us. Throughout this talk, we pretend we work for a successful outdoor and hiking equipment company, and we are going to use the power of generative AI to analyze our sales data, the sales data of these outdoor e-commerce. So our company is a fictitious company called Contoso Outdoor, and we want to analyze our sales data, of course, to keep improving. And we are going to leverage the power of generative AI to build an agent that support us for this goal. So without further ado, let me show you the sample we are going to analyze today. So I have a demo in here. You should be able to see, yes, my browser, where I have my application, which has been deployed through Azure Container App. This application is built with Azure AI Agent Service in Azure AI Foundry, and is based on Azure OpenAI GPT-4o, which is a multimodal model from the OpenAI family. And the UI you see here is built with a conversational AI web framework called Chainlead. So this app basically uses a read-only SQLite Contoso sales database, which contains synthetic data. And when the app starts, it reads the sales database schema, and it adds this info to the Azure AI agent context. Now, this application is fully asynchronous and uses the Fast API framework. Well, so as you can see, we have some conversation starter in here, and I'm going to start with asking for help. So asking to the agent what it can help me with. And so its answer is, I can help with sales data increase at Contoso. Please specify, be more detailed in your request. And so my first request will be very direct on what I need. And what I need is a pie chart, so a visualization of my sales grouped by region. So the first thing we can see here is that the agent basically printed in output the tools it needs to create the visualization. And the tools that the agent needs to create the visualization, it's not something, as you have seen, it's not me saying, please use this function to create the visualization or retrieve the data you need, but it's the agent that understands what tools from the one I've given, the developer has given at the disposal of the agent, which one are the ones helpful to create the visualization. And so in this case, what the agent is using is a function which takes as argument a SQL query, which basically group the revenues by region. And then it uses the results of this query, which is executed against the SQLite database to basically create a graph. And so it needs another tool, which is called Code Interpreter, which makes the agent create Python code and also run it in a Python sandbox. And as you can see, this is the code generated by the agent to create the final graph based on this resulting table. And this is the graph we have asked for, which is quite nice, right? So the agent helped us with the visualization task. Now let's try another prompt. For example, let's ask what beginner-friendly tense does Contoso sells? Here the agent is replying with some generic answers because in reality it doesn't have access to information about specific information about the tense that Contoso sell. They are not contained in the sales database. So what we can do is we can add this information that we have somewhere else. For example, we have here a PDF file containing a product list with the specification of the products. So what we can do is we can upload this file in here and then try asking the same question to see how the behavior change. So again, what beginner-friendly tense does Contoso sell? So in this case, you see that the file has been uploaded to the context of the agent. So basically, the agent is using another tool, which is called file search, to be able to leverage the data uploaded as context to ground its responses. And this time, the response is very much more accurate. So we have specific information about the tense sold by the agent. We have brand name, description, and also the reference of the file where this information has been extracted. Of course, in this case, we just uploaded one file, but if we upload more than one file, it's important to know where the information comes from. So I'm going to challenge a bit more my agent with another prompt, which is asking to basically show the sales for the backpacking tents, but also include description for each tent. So basically, we're asking the agent to retrieve the sales data from the Contoso sales database, which means using the function to execute the SQL query, but also combine this information with the information coming from the PDF file. And it was able to do so, and it is basically creating this table as a result. So again, I can inspect the intermediate step that basically led to the final result. So the function that has been executed, I can inspect the file from which the information of the tense has been taken. Nice. Now I want this information to be packed into an Excel file. So I have my sales report into an Excel format. And in this case, the agent is using again the code interpreter tool, to basically create the code needed to convert that table into, or basically write that table into an Excel file. And inside this sandbox, the code is executed, and the result is this Excel file in here that I can read and I can also download. So this is my table, but written in Excel file. Cool. So that was it for the first demo. Now I'm coming back to the deck and to Marlene, so she can take it over from here. Oh, we cannot hear you. I think you're on mute.
Oh, yes, I'm muted. Sorry, thanks. Yeah, we're going to go back to the slides. And that was a great demonstration from Carlota in terms of how Contoso Sales Agent works. It's a really cool agent to be able to do some practical sales analysis with a large language model with LLMs. But now we're going to actually dive in and figure out how it works. So one of the things when you're getting started with AI agents is that you have so many different frameworks to choose from. So I would love to know, actually feel free to put it in the comments, what frameworks are you using? What's your favorite framework for building agents? I know some people use semantic kernel or AutoGen or LangChain or LangGraph. Those are some of my favorite ones. But let us know which framework is your favorite at the moment for building agents. But if you have used any of these frameworks, something that you probably know is that oftentimes you have to handle a lot of extra developer things, like you have to handle the state, you have to figure out some context that you want to pass through to the agent, or connecting lots of different tools and orchestration and things like that. And that can be quite complicated, especially if you're new and building your first agent. So today we're going to talk about Azure AI Agent Service, which is a great way to start, especially if you are building your first agent. One of the reasons for this is because it removes a lot of complexity from building. And it does this by being able to allow you to quickly build and deploy and scale AI agents. And the first thing that I'll talk about is that you are able to develop in a simple way. So it handles a lot of the state management and your context management. So deciding which tools to call when. The agent service is able to handle all of that for you. So you don't have to build all of those things from the ground up like you would maybe with another one of these agent frameworks that we talked about. A second thing is that it's helpful. It already comes built in with lots of different tools and knowledge tools as well. So actual tools that you can use for taking action, or things that you can use to do things like RAG. So those come built into AI Agent Service. The second thing is that it has support for a large range of model families. So if any of you have used GitHub models, I think Pamela talked about GitHub models yesterday, or if you've used Azure AI Inference SDK, you know that we have a lot of models available, whether that's the OpenAI models or Phi, or whichever, the Llama 1, Llama 4 just came out, for example. All of those are included in Agent Service already for you to use right away. And then a final thing is that you have built-in enterprise readiness. So if any of you have been building out enterprise level applications, you'll know that safety and privacy are a big part of building those tools, and security is a big part of that. And Agent Service allows you to be able to already start with enterprise grade security and readiness. So some things to call out on this in terms of why Agent Service is enterprise grade ready in terms of security. The first thing is that it comes with some tracing and monitoring so that you are able to figure out what's happening with your agent. So you don't have it, when you're building out AI agents, usually one thing to note is that they will have access. If you're using things like RAG or file search, they'll have access to sensitive data. And so if there's customer data in there, you want to make sure that that data isn't going to be misused, or some person is not going to inject something into your data or into your SQL database, and then it's a nightmare happening. And so we have some things to be able to protect from that. Some of the things, like I mentioned before, we have support for tracing and monitoring, ensuring that the AI agent itself doesn't hallucinate. The second thing is that we have content filters so that you're protecting against things like prompt injection, because you can already see if someone puts in some malicious content in a prompt, we'll be able to pick that out with the content filters. The third thing is that you can bring your own storage and search for data handling. So you don't necessarily have to use our storage or whatever it is. You can just plug in whatever storage you want. And then the final thing is that there is private virtual network support. This is something that's coming soon. I'm not sure if it's already there. I know it was coming soon, but I'll have to just double check if it's already landed. But this is something we're working on as well for security. And then also, yes, keyless authentication is already set up for you. You can use that right away in Agent Service. So going back to Contoso Sales Agent app and how it's actually built under the hood. The first thing is that you saw the front end that Carlota was demoing. That front end is built with Chainlit. I'm not sure how many of you have used Chainlit before. It's very similar to Streamlit, but it's quite nice. It's a really nice UI. That's what we were using to build that out. And then you also have this query function where the user can send in a question to the LLM, to the agent from there. So that's what the front end is made of. And on the back end, we're using AI Agent Service, and AI Agent Service has several things going on there. The first is that it has instructions. So it has the base instructions, which is the base prompt that will tell the agent, this is how you're supposed to behave. The second thing is that it has a model that's driving the agent. So in Carlota's example, we're using GPT-4o to be able to drive the agent to answer our questions. And then it has access to these 4 tools. So that specific agent was using function calling to be able to access the database. It actually uses a function that connects to an SQLite database, and then what the agent does, the LLM then generates a query for the user, does a function call, figures out that this is the correct function to call, sends a message to say, okay, this is the correct function, and then that function to query the SQLite database is then run with the query that the LLM has generated. I'll talk a little bit about that in a little bit more detail in a second. The second thing is it also has a code interpreter. So we saw that Carlota was able to generate a pie chart, and that used some Python code under the hood to be able to generate that pie chart with the numbers. It also has access to file search for RAG and also some access to Bing grounding. So if you're searching for information on the internet as well. If you were here yesterday, you probably saw this diagram, a little bit of it broken down, but this is how AI Agent Service actually works in action. So there are 5 key steps. I need to update the slide because it says that there's 6, but it's supposed to be 5. And the first thing is that you're going to create an agent. Second step is that you're going to make a thread. The third step is that you're going to run the agent. And then the fourth step is to check the run status. And then the fifth state is actually the agent displaying the response to the user. So let's walk through that step by step. So the first thing we talked about is that we're actually going to create the agent. With Agent Service, to do that, to actually create the agent, you have some code, which I think at the end, we're going to share the code for how we built Contoso Contoso Sales Agent specifically. But firstly, the prompt that we're giving the sales agent is we're saying that you are an advanced sales analysis agent for Contoso, specializing in assisting users with sales data inquiries. That's the base prompt we're giving it. We also gave it some extra information as well in those instructions for the base prompt, and you can read that in the GitHub repo. But that's pretty much where we're starting. Then we're choosing the model. We chose GPT-4o, and then we're connecting it with these different tools that I mentioned before. Once that's done, we have a thread. So threads are just a unit of conversation. So this is where you're going to keep all of the messages from the LLM, from the agent itself, and from the user. So you can think about threads like a group chat where you are keeping track of all of the messages. So the message is sent in, the message is going out. That is what's happening in a thread. And this is really useful in the future if the agent needs some context about the previous conversations. It has that memory, so it can go back into the thread and think, oh, the user asked this a while ago or something like that. So that's the thread. Then after you've created the thread, the user will go ahead and say, tell me the total sales by region. So the agent is going to look at that question. The LLM will look at that question. It's going to make a function call. And in that function call, it's going to look at a function, all the functions available, or all the tools available as well, and decide based on what the user has asked for, what can I actually do and which function should I call? So it decides to call the querying the SQLite database function. And then it responds to the user once it has the information returned for it. So we can see that again, the user will ask, can you show me a pie chart? In this case, the LLM will look through all of the functions available or all of the tools available and see that, okay, I can't use the database function again. Now I need to use some Python code. So I need to run the code interpreter function and then create and generate a pie chart. So this process is happening through, like I've mentioned this several times, but this process is mainly happening or revolving around function calling. So function calling is the capability of LLMs to take in user-defined functions as inputs and generate structured outputs. So you will probably build out your own function. So I'm not sure how many of us are Python developers or JavaScript developers or Java developers, but whatever language you're writing your code in, you probably have written out a function before. And when you're writing out that function, usually you'll have a string, a doc string that you will add to the function. So that doc string will usually tell the person that's reading the notes about this function what the function does. So if I had a hello world function that I created, I could maybe create a doc string saying, this is a function that types out hello world. And so the LLM will read that doc string in agent service. It'll read that doc string, decide, okay, do I want to call this? Is this something that will help answer the user's question? If it does, it will choose that function. And what it returns is something called a tool call or a function call. And the tool call will have the name of the function that the LLM has selected. And then the agent itself the LLM itself does not run the function. It just takes the name, and it also returns the arguments that should be passed to the function. And then after that, it sends that to your code, where you will have some logic in your code to then run that specific function that the LLM has chosen. So again, like I mentioned, we will have some examples for you in the repository that we'll share of function calls, of tool calling, so that you can actually see what this looks like in the code. But that is pretty much when you're seeing an LLM using some code, or when it's selecting one of the tools, it's usually using function calling to be able to do that. So I'm going to hand over now to Carlota, who's going to give us another example of a demo with function calling.
Yes, of course. Thanks, Marlene. Okay, I'm sharing my screen again. Perfect. So basically, in the first demo, I've showcased to you the agent application a bit like a black box. So now we are going to break it down and look at the code behind, especially we are going to look at the backend code. So of course, this code is open source, is public, so you have the link, so you can also replicate them on your own and go through it at your own pace. But we're going to have a tour right now as well. So basically, the main logic of our application is in this main.py file, where first of all, of course, we import our environment variables, and we set up things like the agent name, the project connection string. So basically, the API endpoint we need to connect to the Azure AI services in Azure Foundry, the model we are going to use, which is the engine, we said, of our agent, and so on and so forth. And then the first thing we do is we specify the function that we want our agent to be able to have at its disposal. So the function that Marlene was previously explaining. In this, we can provide a set of functions that the agent can use. But in this case, in this example, we are going to provide just one function here. So let me go to the definition so you have an understanding of what's going on. So this function is the one we have used to query the SQLite sales dataset to get, for example, the sales by region. So it takes as input the query, the SQL query, and it executes the query against the SQLite database of sales data, and then it returns the result as a JSON. The nice thing of the Azure Agent Service is that we can basically, with this syntax in here, we can specify the description of the function. We can specify the parameter and input and output. So basically, the model has an idea of what this function is for, and can decide when it should be used and with which arguments. And then, as Marlene was explaining, the function is executed programmatically, as you have seen in the method I've just showcased to you. And then another important thing is the instruction file. So we're declaring here an instruction file. Let me show you, which is this one. Which contains a few information, some context for the agent. So first of all, what is its role? The role is to assist Contoso users with sales data, the tools at its disposal. So we are saying that it can rely on a SQLite database, and we are going also to. We also have here a placeholder for the database schema. So at runtime, we can fill in these placeholder with the actual schema of the database. And then we are going to tell the agent, look, you have these function defined that you can use to basically execute the query against the sales data set. And then we also have some content guidelines, some query guidance, so which kind of queries the agent can help with, and some safety guardrails as well. So coming back to the main script, what we do here is we add the function or functions, if we have more than one, we just defined as part of the tool set at disposal of our agent. And then we initialize our agent. So we connect the agent to the SQLite database containing the sales data. We load the instruction file by replacing the placeholder of the database schema with the actual schema. We retrieve runtime. And then we initialize here our agent by specifying the model. We're going to rely on specifying instructions, the tool set, so the function in this case we have specified before, and then we create the thread. So what we have called a thread, which is basically the conversation session between the user and the agent, where we're going to append all the messages between the two. Nice. So let's run these Python script so you can see the agent in action. So we are starting the agent in here, creating the thread, and let's submit a first prompt. Like let's start with what are my sales by region. So always asking about the Contoso e-commerce sales. As you can see in here, we see that the agent is calling the function async fetch sales data using SQLite query, so the function we just have analyzed, with this query in here, which summarizes the revenue by region. And then this is the output. So basically, this is very similar to what we have seen in the UI, but we are running it in the terminal. And then if we want to submit another request to challenge a bit our agent, we can try another one we have used before, which is create a valid pie chart to show my sales data by region. So this time you see that the agent is failing in here. It's saying, okay, I'm unable to create a visual content directly. And that's because we just enabled so far function calling. We need to add some more flavor to our agent to be able to create visualization. And this additional flavor is the code interpreter tool. So let's exit in here and let's do exactly that. So coming back to our code in here, we are going to uncomment this line, which basically specify the file path of another instructions file, which is very similar to the one we have seen before, but in addition to the function that execute the queries against the SQLite database, we are saying to our model that it can also rely on the code interpreter tool to generate and execute code that is able to create visualization. And then the other thing we need to do is adding the code interpreter tool, initializing the code interpreter tool, which, as you can see, is a built-in tool for the Azure Agent Service. So you don't need to, add. You need to add just 2 lines of code, basically. And then we are going to add this code interpreter to the tool set at the agent's disposal. So now let's run the app again, and let's see how the agent behavior changes with respect to the same query. So we are going to ask again to create a varied pie chart. And this time it should be able to do that because it has the tool needed for that. So first of all, it executes the query again. So of course, it relies again on the function we have seen before because it needs the information from the sales data from the SQLite database. But then it also relies on the code interpreter to create the visualization itself. So if we go into the files folder in here, we can see the resulting graph, which is pretty similar to what we have seen in the UI. Nice. Next, let's try another prompt. Again, let's challenge a bit our agent, and let's ask for what brands our e-commerce sell. Again, it kind of fails. So of course, a generative AI model will always try to give me an answer, even if it doesn't really have an accurate answer for me. So it kind of, it's trying to tell me some generic information about the tents that Contoso sells. But the reality is, again, as we have seen in the UI, right now, the model doesn't have access to data which are specific to the products. It does have access only to basically sales data. So again, we need an additional bit in here. We need to add another tool, which is another built-in tool of the Azure Agent Service, which is called file search. So let's uncomment this line in here, where we are going to enable this additional instruction file. Again, very similar to what we have seen before, but in addition to the function and in addition to the code interpreter tool, we are telling to the agent, look, you also have a vector store for additional Contoso product information. And let's see how we create this vector store on top of the file containing the products catalog of the Contoso e-commerce, which is the PDF file I have shown to you before. So basically, we are uploading this file in here. And this path you see here, this TENS datasheet file, is exactly the path to that PDF. And then we are building a vector store on top of the file to be able to basically use and optimize vectorized search on this data. And we are going to initialize another tool, which is the file search tool, and we are going to enable search on this data. And then we are going to add this file search tool to the tool set. So now, if we are going to run our application again, we can see another change of behavior. First of all, it is uploading the file and creating the vector store on top of the file that contains the product catalog information. And then if we ask again the same question, so what brands of tents do we sell? This time, the agent is able to retrieve this information, to provide me with accurate information, because it retrieved information from the PDF file I've just uploaded, or better, the vector store built on top of the PDF file. Nice. Let's go ahead and let's ask for the beginner tents that our competitors sell. So now we are basically challenge the agent again, because there's no information about competitors in the data we have provided. Neither in the Contoso sales data, SQLite database, but also there's no information about competitors in the PDF file we have uploaded. So in this case, we can rely on another tool, again, an additional tool, which is a built-in tool of the Azure AI Agent Service, which is called Bing Grounding. What I've done here, I have created an additional resource, which is called Bing Grounding resource, and I've connected this resource to my project in Azure AI Foundry. And this enables my agent to perform a web search on Bing to retrieve information that it is not able to retrieve from a vector store or other data sources we have connected. And again, I also have an ad hoc file of updated instructions, where I'm basically listing all the tools at the disposal of the agent, which are the function, the vector store, the code interpreter, and also the Bing search tool to search on the web for competitors' information. So if we run again for the last time, if we execute again this application, now we have 4 tools at our disposal. We have function calling, we have code interpreter, we have file search, and we also have Bing search. So now if we are going to tell the same question about competitors, the agent knows that it can rely on the, so it is telling me I can search online for current competitor offerings. Yes, please search online. And here are some beginner camping tents offered by competitors, and this information has been retrieved from a web search. Nice. So I know we have some more things to cover, so I'm going back to the deck, and I think Marlene has some more for us to cover.
Thank you, Carlota, for that practical demonstration. That is how function calling works. The next thing we are going to talk about is what happens if we want to build out a multi-agent application. So you want to use more than one application. So let's start off by defining what is a multi-agent pattern. So we can say that an AI multi-agent system consists of multiple intelligent agents that interact and collaborate to solve complex tasks, share information, and achieve goals autonomously or semi-autonomously. And this pattern can cover a number of different use cases. It can include really simple tasks, such as generating a report, or as complex solutions as automating large-scale workflows. So this is super helpful for a number of different reasons or workflows. So I'm going to talk about some different frameworks for you to use when you're building out different agentic solutions. So like I mentioned, if any of you were there yesterday, you probably heard me talking about how when you're deploying a single agent, you would just use Azure AI Foundry to deploy a Azure AI Agent Service. So that would be fine for building out a single agent. But when you're wanting to move on to building these multi-agent solutions, you want to use an orchestration framework that is going to allow your different agents to work together in a way that's coherent and will be able to manage everything that's going on. So Microsoft has two SDKs that are available for you to use when you're building out these multi-agent solutions. The first one is AutoGen, which we talked about is AutoGen is coming out of Microsoft research. This has all of the cutting edge research on agents. If you want to try out Swarm, if you want to try out group chats with agent, there are so many options, and they have a great cookbook. I know I'll try and see if we can find a link to the cookbook for different examples that you can build out using AutoGen, because they have lots of the latest patterns for building out multi-agent solutions. One of the advantages of that is that you can be really creative and create really cool solutions. But one of the disadvantages of using AutoGen is that if you are using the SDK, there's going to be lots of breaking changes because they're making updates all the time. So we wouldn't necessarily recommend it if you're using this in production. Now, if you want to build an application that's more stable, we would then recommend semantic kernel. And semantic kernel, so in this case, semantic kernel is more for production-ready multi-agent solutions. So if you are wanting to build something that you are going to deploy directly to customers, this is something we would suggest. Semantic kernel usually has a lot of the latest updates, but it's going to be pretty stable, and so you won't really have as many breaking changes. I know yesterday we had lots of questions in the chat about what happens if you want to use different frameworks. You don't just want to use AutoGen or semantic kernel. You are allowed to do that in this hack. You can use LangGraph, you can use Crew AI, you can use whatever you would like when you're building out your solution. We just recommend these because these are coming out of Microsoft, so we can really, we have lots of resources for them. But there will be different talks throughout the next few weeks on different frameworks like LangChain, for example, and building out with that. So let's look at how we would implement something like a multi-agent solution. So the first thing that we want to think about when we're getting started with this is like, why do I actually want to use a multi-agent solution? I don't think this should be your first go-to thing to do because it's slightly more complicated. You have a lot more things to be managing if you want to build out something that's multi-agent compared to a single agent. But there's a number of reasons why you might think to yourself, this is the best solution for me. The first thing is that maybe you don't want loads of prompts in one single agent. If you have lots of different prompts where you want different agents to be doing different things, it's not great to have so many prompts in a single agent space. And so that's a great reason to remove the complexity when you're doing that. The second thing is if you have lots of tools that you want an agent to have access to. As you add tools, the quality of the response is probably going to go down at a certain point. I actually was at a meetup yesterday where there was someone from OpenAI saying that they saw that the threshold of using tools is about 29 tools. So once you get to 29 tools, that's like a really arbitrary random number, but that's what she said. She said that if you pass 29 tools in a single agent, you're going to see some deterioration. I think she even said in potentially just generally, if you're using too many tools, you're going to see some deterioration in how your agent is going to perform. So typically, if you're using a lot of tools, you want to consider using an orchestrator and going the multi-agent route. So that's something else that you should do. A third and final thing that I'll mention is that if you want specialized agents for different tasks, that's a great option as well for using or building out a multi-agent solution, is that you're probably going to get more accurate results because each agent is just focusing on one thing. Whereas if you're using these other ones, sometimes the answers are not going to be as great, and you can't really improve and iterate on each task as you would want to. Whereas it's so much easier if there's a specialized agent for one thing. It's easier to debug, easier to improve it over time, because you can pick that out and say, this is the agent that has the issue, and improve it over time. So this is on the screen. This is an example of actually implementing the solution Carlota shared with us as a multi-agent solution. So here we can see that, these are our different agents are structured in this way, where we have, instead of having everything in one, we actually have a separate SQL agent that will be able to interact with, a custom function that we write to be able to access the database, and a code interpreter. So this SQL agent will just focus on code and focus on anything related to the database, which is great. The second agent that we would create would be our data analyst. And this one would directly just focus on getting the information that I got from the SQL agent and deciding what to do with that information. How do I analyze that data? How do I show that data in the best way possible? How do I grab resources from Bing search? How do I grab information from file search, and bring that all into a data analyst space? So that's what the second data analyst is doing here. And then the user proxy would be a second agent that is able just to interact with the user and is able to monitor what's going on and keeping track of the conversation as well. So this is what it would look like if we wanted to take what we had initially and then breaking that down into specialized agents that can focus on a single task. Some things to note as well is that the number of agents, as the number of agents in your system grows, the burden of maintaining those agents also grows proportionately. So you also want to make sure that you're building in evaluations into those systems so that you are able to monitor what's going on and keep things working as expected. So we will have a session, I think, a little bit later on evaluations and quality checks and things like that. So I think that's pretty much all I have to say for multi-agent solutions. Like I mentioned, please feel free to experiment with different frameworks when you're building these out. I think I'll put in an example of a version of this with Contoso Creative Writer, which is another project that we have for building out a multi-agent solution, but it doesn't use an overall orchestration framework. But yeah, I'm going to pass it over now to Carlota, who's going to just give us a final summary and some takeaways for us.
Yeah, I've seen some questions in the chat, so maybe we can just take some questions before wrapping things up. What do you think, Marlene?
Yeah, I think that sounds great. Let's do that.
Cool. And by the way, Pamela is doing a great job, answering lots of questions. So thank you, Pamela, and thank you everyone for the engagement and for keep the questions coming. So I've seen a question about by Suhi. I hope I'm pronouncing this right. Who is interested in how the online search is implemented. So the online search I've showcased is basically relying on a service which is called Bing Search. Bing Search Grounding basically is a built-in tool which is part of the Azure AI Agent Service in Azure AI Foundry. So basically, with a couple of lines of code, the one I have shown before, you can enable this web search. So you don't really need to implement it yourself. It's a built-in service that basically use the user query to search the web, and then the results are added into the prompt. So the prompt is augmented with the result of the web search. So the agent can ground the responses on the results of the web search. So that's how this is working. And then there's a question on, there's a couple of questions on the multi-agent scenario just covered, Marlene. One from Vincent was, how do different agents communicate with each other? I don't know if you want to take this
Right.
one, Marlene.
So, it depends which orchestration framework you're using. For example, let me share the link here. I'm going to share in the chat the link to the AutoGen examples that we also have. And if you look at the beginner's course as well, the AI Agents for Beginners course, you'll see different examples of this. But for example, when you're using, when you are using something like AutoGen and you're using it, there's a specific pattern design style called Swarm, which actually came out of OpenAI. And with this pattern, it uses something called handoffs. So you can specify specifically, so maybe you have a planner agent, and that planner agent, you'll be able to give it, to specify to it that when you are done with the task, you can hand off next to these other agents. And so the orchestration framework itself will have a setup to be able to allow that planner agent to direct the path on where to go next. And so it's usually going to be the, maybe a planner or orchestration agent that is making a decision on which is the next agent that should run. And then the orchestration framework is going to decide on the design, that will control the design pattern in terms of how the next agent is actually called. But you'll usually have something called a planner agent or an orchestration agent that makes those decisions. And it does that usually, there's like a group, there's different implementations of it. So it's really, I want to say, orchestration or package specific. I hope that might make sense. I would recommend checking out AutoGen's Swarm examples. I really like them. I think those are particularly good. I pasted a link in the chat to that.
Perfect. Thanks, Marlene. And then I've seen an interesting one from Luke. So the question was, is the goal to have the agent behave as a desktop assistant and replace other applications and allow for a single pane of glass? Yes, I think the short answer is yes, in a sense that agents for sure are, revolutionizing the user experience. So the way we interact with applications. AI is democratizing in some way also the access to how we interact with applications. So we can basically create code with natural language. We can do create assets, create images with natural languages. I mean, it's the use of natural language to interact with models has definitely revolutionized the way we interact with applications, and especially agents is automatizing lots of tasks. Yes, in the future, I see the agents as kind of the user experience we have with lots of applications. You can see it already on, for example, the Microsoft ecosystem and all the tools for the all the tools for the Office suite, for example, creating, or having Copilot helping you creating PowerPoint decks summarizing meetings in Teams. So you can really interact with agents to retrieve information from the application. I don't know, Marlene, if you have anything, any other insights to share on this.
I think that's probably right. I think that, I don't have anything to add on. I would agree with you. Yeah.
Nice. And then, there's any other questions you want to take, Marlene, before the
our takeaways? I think Pamela has posted a lot of helpful links. There's a link in the chat to a multi-agent solution that Pamela shared as well. And there was a great question about if you can use this with local LLMs like Llama or something like that. Yes, you can do that. So I think that's something to keep in mind. That's what I would say.
Nice. So I'll be cautious about time. And
one thing I wanted to say to Vincent, to W Vincent, is that no, the LLM generates the SQL query on the fly. So this is like happening dynamically. So that's all I'll say. Go ahead, Carlota. I just wanted to answer that.
Yeah, no, thanks for taking that last question. So what we have seen today in this presentation, we have seen how to build agents with the fully managed cloud Azure Agent Service. We have seen the built-in tools that you can use within Azure Agent Service, like enabling web search through Bing Search, enabling functions execution through function calling, code interpreter to create and execute code, and so automatize tasks, etc. We have done also an overview of where Azure Agents sits with respect to semantic kernel, AutoGen, and other frameworks. And so the next step is really for you to build your own agent, maybe using Azure Agent Service or other frameworks. Last but not least, again, this is the repo where you can find all the material for this session. So the deck, the code, everything. So feel free also to use GitHub issues for any feedback you have. Another resource that might be really helpful, I'm going to paste this link in the chat in a moment, is our open source curriculum, which is AI Agents for Beginners curriculum. Basically, you are going to find it's based on different chapters, so you can go through the whole world of agentic AI, not just Azure Agent Service, but lots of other frameworks, different architecture from single agent to multi-agent, and so on and so forth. So I'll paste the link in the chat.
Yeah. Thanks, everyone. I think that's pretty much all we have after the link.
Yeah, and I think we are also on time. So
great.
Thank you so much for joining.
Everyone. See you at the next one. Good luck hacking.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.